Hello and welcome back to part 3 of the GeoPython Advanced workshop. In this part we're going to be looking at how you can create custom PowerPoint reports from your simulation results. Let me first show you how the basic principle works. Inside your project folder you will find a folder called PowerPoint Reports. In there's a file called PPT template. You don't have to open it right now, you can just watch me showing you the file. I will open it. And you can see that it's actually an empty PowerPoint presentation. But if you go to the master view, to the slide master view, you can see that there are several slide masters defined in this file. And if we go to one of these slide masters, you can see that there are placeholders, which are just standard placeholders that you can add with PowerPoint with this placeholder function up here. But they all have a text defined, and this text is crucial for the report generation later because it identifies the element of the slide that you want to define. So again, this template file, it's called PPT template, is what we're going to be using, and it's already in your workshop materials. But you can easily create your own template files. But the basic idea is that in order to generate a single slide of a PowerPoint report, you pick one of these template slides, for example this one, and you specify the content for each of these placeholders. For example, you specify a string, which the title gets replaced by. You specify 3 pictures to go into these frames, basically, and you specify 3 captions which go below the pictures. And then your slide is done and it's added to the presentation that you're currently constructing. Now let's say you want to add a master slide here. Just go down here, right click, add layout, and here you can define your custom master slide. There's already a placeholder here, and there are placeholders down here. You can delete them. And for example, you can go here, insert a placeholder for an image, and just do it like this. And then you give it a unique name on this slide, basically. And you can position it wherever you want. Now let's go back to the slide list here on the left hand side, and I want to show you one slide that you're going to be using in the next experiment, namely this one. This slide has a placeholder for a title, for a picture, and for a picture caption. And you can see that it's the second layout slide down here. The layout slides start counting from 0. This is important to remember. So this one is slide 0, this one is slide 1. So if we want to make a PowerPoint slide based on this template, we're going to be referring to it using the number 1. The advantage of this approach is that the design and the code logic is separated. So someone who doesn't know how to write Python code can still change the design and replace the template file, and you rerun the macro and the resulting report is going to look different. Now I'll close this template file and go back to the workshop folder, project folder, and I would just like to show you inside the PowerPoint reports folder. Again, we have the template file, but there's also an image file that we're going to be using for our next experiment. If we want to look at it, we can see that it's a simple geodetic structure image, and this is what we're going to be using for our picture in our slide. Of course, using GeoPython you can also automatically generate these 3D images, but please refer to the beginner's workshop for that. So now to get started, please go back to Notepad++ and open the workshop6.py file again. And now again click File, Save As. But this time I would like you to navigate to this to the subfolder PowerPoint Reports. So inside the folder called Project folder is PowerPoint Reports, and here we're going to be saving the file as ppt1.py. And now first thing I would like you to do is just get rid of all the code, so Ctrl-A to select all and Del to remove. And now we start with a Python macro which will generate a simple PowerPoint report. First of all, please type import gd.ppt and then rep equals gd.ppt.report generator, double quotes, ppt template.pptx. So what this does, the import statement, it will load the built-in GDPPT module, which contains our report generator class. It then creates an instance of this class and passes the template file. So basically, it tells the class to use this ppt template pptx, which we saw earlier, as the template file for this report. And this object is then stored in the variable rep. And this is what we're going to be using to add slides and add content. So let's add a slide to our PowerPoint report. Write SL equals rep.add_slide 1. Again, as I mentioned earlier, the 1 refers to the template slide that we want to use. So we want to use the slide which has a title, a picture, and a picture caption. And when we call this add slide function, we will get back a slide object, which then allows us to define all these individual elements for this slide. For this purpose, we write sl.add_text, then double quotes title, and this is the title text. And here again, it's important to remember the names of these placeholders. And the placeholder for the title had the key title. So that's what we're going to refer to here. So basically, we're telling Geotic to, for this slide, to replace the title placeholder by the text. This is the title text. Then we continue by replacing the picture. So SL add picture. The picture on this slide was called picture. And here we now define the file name of the picture. It has to be in the current directory on the disk. And we saw the image example PNG, and this is what we're going to be inserting here. And finally, we define a picture caption, sl.add text, picture caption. This is the picture caption. And then we save the whole presentation by saying rep.save quotes example pptx. So again, what this does, it opens a report generator based on these template slides. It then adds a new slide based on this specific template slide or master slide. And then it proceeds to replace all the placeholders in this slide by actual content. Namely, the two text boxes title and picture caption are replaced. And the picture is replaced by the concrete PNG file that we have on disk. And then the presentation is saved under the name example pptx. Now please save the file by pressing Ctrl S. Now let's go back to Geodict. And the first thing we need to do is change the project folder, namely to that folder that we just used. So go to File, choose Project Folder, select Project Folder. And inside your previous project folder, go to the subfolder PowerPoint Reports. Double-click it and click Select Folder. Now we go again to the macro execution dialog by clicking Macro, Execute Macro Script. And again, if the macro file should be missing here that you expect, then just click Refresh. But it's here, so click ppt1.py and click Run. This is a very fast process. Now go back to the Explorer go to the PowerPoint reports folder, and now you can see that there is an example.pptx. We can open that, and we see the slide that we have just generated. Let me just put that next to each other with a notepad. So you can see here we have used the template slide 1, which had the three elements: the title, the picture, and the picture caption, and we've replaced them accordingly. So this slide was created where the concrete content was placed instead of the placeholder. Afterwards, the report was saved. Of course, you can also call add slide multiple times with different templates, and each time another slide will be added before you finally save the whole report. Now let me give you a quick overview of the content types that are supported. You will also find this in the handout materials, by the way. So we already saw the add text function, where you give the placeholder name, the text to be inserted at this location, and what you can also specify, but don't have to, is the font size. So you can actually change the font size of the text that you're inserting. For pictures, we've already seen this. We can call add picture, give the placeholder name, and specify the name of the picture file. Furthermore, we can also add tables, and we're going to be seeing that in the next example as well, where you specify the placeholder for the table, then you specify the two-dimensional table data, so the content of the cells, and you can also specify horizontal headers and vertical headers for the table, and you can specify a font size. And you can also add movies by calling sl add movie, giving the placeholder name and the path to the MP4 file that you want to add to the presentation. Next, we're going to generate a plot and a table from GeoPython and add that to a PowerPoint slide. But first of all, let's go back once to the template file. And again, you don't have to do this. I'll just show you something. And the master slides. And now what we want to do, what we want to use here is slide 7. And again, those start counting with 0. So this is 0, 1, 2, 3, 4, 5, 6, 7. So we have this slide that we want to use, this layout slide. And this slide has a title, a table, and a picture placeholder. And so if we want to make a slide based on this, we need to give a content for the title, a content for the table, and a content for the picture. And this is what we're going to be doing next. So go back to Notepad++. And now what we're going to base our macro on is the workshop5.py file. So open that again. That was in the folder above. So go there, open the workshop5.py. And first go to File, Save As. Go again to the PowerPoint report subfolder. And save it as ppt2.py. Now we can fold away this function again if we want. And as you might remember, this was the macro which generated a plot of permeability over the SVP values. And we'll keep this part of the macro because we want to use this plot and directly insert it into a PowerPoint report. Now let's make this full screen maybe. And as you can see, the last thing we did in our macro was write the picture file permeabilities.png, and this is what we're going to be using. But let's first start, as we did in the other case, import gtppt. Then we generate a report generator. Again, based on the same PPT template, PPTX. And of course, as I said, the template defines the design. So for your corporate design, you can have one single template file basically, which has all the configurations of slides that you might need, and just use that for all your different reports. Now we add a slide, SL equals rep add slide. As I said, based on slide number 7. And then SL add text, and we replace the title by flow permeability versus SVP. So next we add our picture, SL add underscore picture, placeholder is called picture, and the file that we want there is permeabilities.png. And now what we need to do to prepare the table, we need a two-dimensional array which contains the cell values for that table. So first of all, we start with an empty list. And this list is going to contain basically the rows of the table, whereas each row again is a list. So this is going to be a list of lists. And we construct this list based on our SVP values and perm values lists that we have above here. And we do this by iterating over them in parallel. So for SVP, perm in zip SVP values, perm values. What this does, it iterates over these two lists in parallel. So the first time the for loop runs, we get the first SVP value matched with the first perm value. And in the second time, we get the second SVP value and the second perm value. So each of these values always correspond. And now we add this to the table data by saying table data.append, round brackets, and then square brackets, SVP, perm. So again, this is a list, and this is the row that we're adding, and we're adding this to the list of lists here. And now we only have prepared the data, so finally what we need to do is we need to add this to the PowerPoint report. So we do sl.add table. Placeholder is called table, and we have to specify the table data here. And what we can also do is we can specify a horizontal header. So horizontal underscore header equals, and this is again a list with entry for each header. So we put string svp% and flow permeability in square meters. Close the list, close the function, and finally we save the whole report as, say, plot and table pptx. Now again, we already had this part from the Workshop 5 macro earlier, and what this already did for us is have the SVP values in a list, collect the corresponding perm values in this list, perm values, and it generated the plot and produced this image. And we're using all these three parts down here now. Namely, we use SVP values and perm values to fill our table down here, and we use the image from disk to replace the picture placeholder. Now I made a mistake here because I wrote gdt.ppt. This is of course supposed to be gdppt, as the module name is gdppt. And now please save the file by pressing Ctrl S. And let's go back to Geodik. Again, macro, execute macro script. Might have to click refresh here to see the ppt2.py. Now select it and press run. Might have to click override here. And it now again runs the study from SVP 5 to 45 and computes the permeability for each case, and collects them in the two lists, and also writes the permeabilities.png, and then finally generates the PowerPoint report. Now if we go to our project folder again in Explorer, namely the PowerPoint reports folder, we should see the file plot and table here. And if we open it, we see that that it has done what we wanted. So we have a single slide where the title has been replaced, a table has been filled in, and a custom and a custom plot has been inserted as well. And by this method, you can basically aggregate all your simulation results however you want. And as I mentioned earlier, you can also include pictures, which is covered more in the beginner's workshop. So you can render 3D images of your results, for example, and also include them. So just tell Geodik to save an image, which you can record, and then use that image and replace a picture placeholder by that image. If you had difficulty following, note that all the code, including explanations, is also found in the handouts that we shipped in your workshop materials. Also, the actual macro files as created by Math2Market can also be found in M2M results subfolder. We have also included two more complicated examples of what you can do with the report generation. But I do not expect you to type all this. I'm just going to show you some macros now, which are also included in your workshop materials. So first of all, go to Geodict again. Now change the project folder. So choose project folder, select project folder, and go to the Flowdict report subfolder of the PowerPoint reports. And click select folder. So project folder, PowerPoint reports, Flowdict report, click select folder. And if we go to macro, execute macro script, and unfold this Flowdict report folder, you can see that there is two main macros here. There's a create and simulate macro, and there's a Flowdict report macro. The create and simulate macro does something similar as we've done before, so it creates some structures and runs simulations on them, but they take a little bit longer, so that's why I split this in two steps, and the results from step 1 are already in that folder. So if you just want to see the result, just go to step 2, Flowdict report, and click run. And this now actually includes 3D image rendering. Now let's look at the result. Go to the Explorer, go to the PowerPoint reports, and there to the Flowdict report subfolder. And there you can see a new PowerPoint file called Flowdict report. Open it. And here you can see what can be done with the report generator. So for example, you can save 3D images, including visualization of simulation results, in this case streamlines, to visualize the flow through a structure with different solid volume percentages, in this case 10, 40 and 70%. And on the second slide, we see a nicer plot, which is a plot which was generated from within the GDR result viewer. So you can also record that. If you go to the GDR result viewer, you right click on a plot and save that. You can also record that to a macro and generate plots like this. And there's also another table down here. Now I want to conclude by showing you one last example, namely a FilterDict report generation. For this, again, go to Geodict, choose project folder, select project folder, go back up one folder to PowerPoint reports, go to filter efficiency report, select folder, go to the macro execution dialog, unfold the folder, and here again you can see two steps. The first step creates the data and the second step creates the report. And I would also suggest that you split your, if you're actually using this in production, that you should split the data generation and the report generation like this, because often the report generation only takes seconds or minutes, while the simulation might take hours or even weeks. So we can just go to step 2, because again, the data that step 1 generates is already provided in this folder. So go to step 2 and click Run. Now again, go to Explorer. Go to the filter efficiency report folder in PowerPoint reports and open the new report, FilterDict report. What you can see here is a small FilterDict study over a fiber structure being clogged by dust particles. And what we did is we generated different fiber structures where each of the fiber structure has the same SVP, so the same porosity basically, but there are two fiber types and we are varying the proportion of the thin fibers, 4 microns, and the thick fibers, 14 microns here. And what we can observe here is that for the case where we have 100% thin fibers, that the particles do not penetrate very much into the filter, and we don't see any particles making it all the way through the filter, but we can see that there is a huge filter cake built up here instead. Once we start introducing more thick fibers and reducing the amount of smaller fibers in proportion, we can see that the particles penetrate the filter more and more. And this is also reflected if we go to the second slide. This is also reflected in filter efficiency, depending on this is also reflected in the filter efficiency depending on the amount of thick fibers. Again, if there's 25% thick fibers, there's 70% thin fibers. And you can see how this affects the filtration of the different diameters of particles here. So you can see if you have 100% thick fibers, then many more particles will go through the filter. And if it's all thin fibers, then only the very smallest particles will make it through the filter, namely those with 10 E-6 meters diameter here. And you can also see the pressure drop of the unloaded filter depending on the fraction of thick fibers here in the upper graph. And feel free to look at these macros, especially at the step 2 macros, to see how these more advanced reports can be generated. Let me conclude by mentioning some further topics which are beyond the scope of this workshop. The first one would be command line execution of macros. You can run GeoDict from the command line, passing a GeoPython macro, and even pass variable values to that macro. We haven't covered variables as I mentioned, but this is part of the beginner's workshop if you're interested. But if you want to use GeoDict as part of a larger automated workflow, you can do so by just running it in a batch fashion and calling GeoDict with a GeoPython macro to do something, for example. Also, there are additional GeoDict API functions. As I mentioned earlier, in the execute macro dialog, there's a Geo API help button, which gives you a complete list of all of these functions. 2 points that are possible, for example, are accessing the structures. So actually you can access the voxel image and even manipulate it from within Python using NumPy. And you can also access the simulation volume field. So for example, you could do statistics over the pressure field or over the vector field, which is a result of the flow simulation, or over the mechanics, over the stress field, strain field, whatever you need. And one other thing that you can do is you can write image filter for custom image filters for MicroCT import, or actually use external image filters for MicroCT import. We also include some other popular standard libraries, namely NumPy, which allows you to do fast numerics, for example, on structures or result fields, as I mentioned earlier. So if you want to access the structure or want to access the simulation field, actually GeoDict will provide you with a NumPy array on which you can do pretty fast computation. There's also the SciPy library, which allows for further scientific computation, for example, optimization algorithms, interpolation algorithms, integration, derivation. And there's the Matplotlib library, which we used before for plotting. Again, all the documentation can be found online for that. There's the XLSX writer, which allows you to create Excel files from within GeoDict. There's the TensorFlow library, which you can use for deep learning applications, and which we also use in FiberFind AI, BinderFind AI, GrainFind AI, and the new GeoDict AI module. And there is the Pillow library for image manipulation. This, for example, allows you to render several plots and then put them together to a collage or something using that library. And finally, in conclusion, what I have shown is how you can access simulation results programmatically using GeoPython, how you can reorganize your GeoPython code into functions to make them more reusable, how to perform automatic material optimization, and how to create plots and PowerPoint reports based on simulation results. And with this, I will once again be available for questions. Thank you for your attention.